Okay. So this carbonyl compound converted into CH2 group. This carbonyl compound converted into CH2 group. So in this reaction, the reduction takes place. So what is the reduction? Addition of hydrogen or removal of oxygen. Okay, now here removal of oxygen and addition of hydrogen takes place. This is Clemmensen. Okay, this method is useful for aldehyde and ketone converted into alkanes, methylene group, C-double-bond-O converted into CH2 group in the presence of zinc amalgam, ZnHg, zinc and mercury in presence of HCl. The reduction takes place. This is Clemmensen reduction. Okay, the next reaction is very important one, Meerwein-Pandra-Varley. This is the scientist name, very important for short answer question, Meerwein-Pandra-Varley. So in this reaction, okay, aldehydes and ketones are reduced by heating the aluminium isopropoxide in isopropyl alcohol. Okay, so in this, the reaction is specific for carbonyl function can be used for the reduction of aldehydes and ketones. It gives corresponding alcohols. Other reducible functions such as NO2, C-double-bond-C are not affected under these conditions. Only carbonyl compounds are converted into alcohol. See the reaction, simple. See, this is C-double-bond-O or C-double-bond-O R. This is carbonyl compound, okay, plus isopropyl alcohol. Okay, this is isopropyl alcohol in presence of aluminium isopropoxide. This is converted into alcohol, and alcohol converted into ketone. Ketone converted into alcohol, alcohol converted into ketone. This is the, okay. One is oxidation and another one is reduction. One is oxidation. Okay, this is reduction. This is oxidation. Okay, now this reaction is reduction. This reaction is oxidation. What is reduction?
Addition of hydrogen.
So see here, RC-double-bond-O group is there. It is converted into RCH2OH. Here, hydrogens are adding. RCH2. Ketone is converted into alcohol, and alcohol, second one is converted into ketone. In this, only one reaction, oxidation and reduction takes place. Oxidation and reduction within the reaction. So these two types, the reactions are called redox reactions. Redox reactions. Redox means reduction plus oxidation. Reduction plus oxidation within the reaction. Okay, now the compound ketone is converted into alcohol, and the alcohol converted into ketone. Yes or no?
Yes, sir.
Secondary alcohol converted into ketone. And within one reaction, oxidation takes place as well as reduction takes place. So these two in one reaction is called redox reactions. Redox means both oxidation and reduction. Both reactions are possible. These type of reactions are called redox reaction. Example is the scientist Meerwein-Pandra-Varley. Meerwein-Pandra-Varley. So simple. See, once again, see, what is the reaction? See, the aldehydes, ketones. Aldehydes or ketone converted into alcohols, and the secondary alcohols converted into ketone in presence of aluminium isopropoxide. Aluminium isopropoxide. Okay, this is called redox reactions. This is called redox reactions. See, if they are taking cotonaldehyde, okay, na? Cotonaldehyde converted into means alcohol. Yes or no? Clear this reaction?
Yes, sir.
Next, these are all are important. Name reactions are very, very important for short answer question. And another important, this is in the laboratory we can use the Tollens test. It is the identification test for aldehydes and ketones. Okay, just write down identification test for aldehydes and ketones. Identification test for aldehydes and ketones. Yes or no? Identification. Okay, now. So we are taking a such functional group in this aldehyde or ketone. Okay, now to identify this Tollens reagent. This Tollens reagent. See, aldehydes are readily oxidized. They are powerful reducing agents. Aldehydes reduce Tollens reagent to metallic silver. Okay, simple. Tollens reagent. What is Tollens reagent, sir? Means ammonical silver nitrate is called Tollens reagent. Ammonical silver nitrate. So simple. We are taking burette, sorry, test tube, just we are adding with aldehydes or ketones, anyone. If aldehyde adding or ketone, anyone, just adding Tollens reagent. Then heat for 5 to 10 minutes. The test tube side walls is shining like silver. The test tube side wall is shining like silver. That compound is confirmed aldehyde. If not shining, just as this, the compound is ketone. Yes or no? Clear? అర్థమైందా?
Yes, sir.
సింపుల్ గా ఎందుకంటే సార్ ఓకేనా, సింపుల్ ఒక టెస్ట్ ట్యూబ్ తీసుకున్నాం. ఓకే, వీఆర్ యాడింగ్ ద టెస్ట్ ట్యూబ్, వీఆర్ టేకింగ్ aldehyde solution or any aldehyde solution, solid or liquid, and then adding ammonical silver nitrate is nothing but Tollens reagent. We are adding Tollens reagent and heat on flame for 5 to 10 minutes. In our water bath for 5 to 10 minutes. The test tube side walls inner side or outer side, the shining like silver, the shining like silver coating. So the functional group aldehyde is confirmed in that compound. C double bond OH is confirmed. If function, it is the compound does not reduce as Tollens reagent, that is ketone or C double bond OR. So simple reaction, what we said, 1 point. If Tollens reduce the aldehydes, not reduce the ketones. If Tollens positive for aldehydes, negative for ketones. Simple line, Tollens positive for aldehydes and negative for ketones. Okay, this is important one. See, this is aldehyde functional group. This is ammonical silver nitrate. This is called Tollens reagent. See, simple. RC double bond O minus and C. What is the change? Silver is deposited. This is the main. Silver is deposited. See, simple. Aldehydes readily oxidized. They are powerful reducing agents. Aldehydes are reduced Tollens reagent to metallic silver. అంటే Tollens నుంచి ఏం చేస్తుంది, ఇది సిల్వర్ ని బయటకు తీసుకొస్తుంది. ఓకేనా? అమోనికల్ సిల్వర్ నైట్రేట్ ఇస్ కాల్డ్ Tollens reagent. When the test is conducted under proper condition, a fine silver mirror is obtained. Ketones do not give. Yes or no?
Yes, sir.
అర్థమైందా? So these tests valuable for distinguishing of aldehyde. అంటే ఏది aldehyde, which is ketone. ఓకేనా? What is the difference? Differentiated by the Tollens reagent. If Tollens positive for aldehydes, negative for ketones. Clear?
Okay,
Yes, sir.
Okay. So next, very, very important for long answer as well as short answer question. Kenijaro, benzoin and aldol condensations are very, very important. Okay. See, what is Kenijaro reaction? Alpha, without alpha hydrogen. Good bet kondi, without alpha hydrogens. Okay na, aldehydes are condensed. Here, aromatic aldehyde undergo this reaction. Aromatic aldehyde. So simple means, sir, what is aromatic aldehyde? Means ring structure. Okay na, ring structure. This is aromatic. This is aldehyde functional group. Attached with this is aromatic, ante benzene ring, aromatic. So this is called aromatic aldehydes. These are called aromatic aldehydes. What is aromatic means? It follow 4n+2 pi electron rule. 4n+2 ante you know that in first sem maybe Huckel's rule. Okay na, first or second sem benzene its aromaticity. Okay na, what is aromatic nature is? It follow Huckel's rule or 4n+2 pi electrons, 2 electrons, 6 electrons, 10 electrons, 14 electron, 8, like this. They follow this rule. The compound is said to be aromatic compound. Simple difference. Sir, what is aromatic? Aromatic means, aliphatic means open chain structure like this. Aromatic means ring structure like this. Clear?
Okay, sir.
Difference between aromatic and aliphatic? Say yes or no.
Yes, sir.
Yes, sir.
Okay, so this is C6H5. and C double bond OH. This is aldehyde with aromatic ring. Aldehyde with benzene ring, C double bond OH. If 2 moles, when benzaldehyde is refluxed with aqueous alcoholic potassium cyanide with KCN, K plus Cn minus. Cn minus is act as nucleophile. Here, Cn minus is act as nucleophile. See, benzoin, benzaldehyde, 2 moles of benzaldehyde converted into benzoin. 2 moles of benzaldehyde converted into benzoin. This reaction is called benzoin condensation. 2 moles. 2 moles condensation. See the mechanism. You write the reaction simple. This one, 2 moles of benzaldehyde in presence of simple. What is the definition is 2 moles of aromatic aldehydes in presence of potassium cyanide is converted into benzoin. This reaction is called benzoin condensation. Okay. See the mechanism. See, this is Cn minus is a nucleophile. Cn minus is a nucleophile. Attack at electrophilic carbon. What is the nucleophile character means? Nucleophile is nothing but electron efficient compound. Electrophile is electron deficient compound. Nucleophile, negative charge. Negative charge compounds are nucleophiles are called, and they are negative charge and they are electron efficient. Means more electron. Okay, now they attract. If negative attract with which one?
Positive.
Negative,
charge.
positive. Okay. So the C double bond OH. Okay, na? This is benzene ring. C double bond. This is like positive charge. Electrophilic carbon. Cn minus is attacked at electrophilic carbon. They form new bond between carbon-carbon. New bond between carbon-carbon. See this bond. See this bond. Yes or no? Carbon-carbon bond. See Cn. See Cn. There is a new bond formed. And the pi electrons towards oxygen, it get negative charge. Pi electrons towards more electronegative atom, oxygen, it get negative charge. Okay, now. So these two are resonance structures. These two are resonance structures. This is keto form and this is enol form. Okay. Then another molecule. If you are taking in the reaction 2 molecules, 2 aromatic aldehydes takes place to convert it into benzoin condensation. So first molecule is attacked by potassium cyanide, cyanide nucleophile, and they form this structure. This structure is attacked by another molecule of benzaldehyde, and they form so and so like benzoin. Okay, benzoin. This is called benzoin condensation. Condensation means attachment of 2 molecules. Attachment of 2 molecules. Clear?
Yes, sir.
Okay, sir. Okay, sir.
Just you have tried this one. These both are same. Don't write any one. This one also. Just you have to write this one or this one. This one or this one also same. These are the structure is said by resonance structure. Okay, na equilibrium. Okay, na the structure is said by resonance structure. Okay, both are same. Next one, Beckmann rearrangement. Okay, na simple we say Beckmann rearrangement. Okay, na so means rearrangement. Okay, na one position to another position. Okay, na alkyl group attached to carbon to another carbon or another nitrogen. See this typical reaction of ketoxime when treated with reagent like sulfuric acid or phosphorus pentachloride, ketoxime undergo rearrangement. An amide is obtained in Beckmann rearrangement. Ante simple ga benzophenone oxime yields benzanilide. See, sir, what is oxime? See the new word oxime. C double bond N. Okay, one of the lone pair and OH. Alkyl group and alkyl group. Okay, na? If RCH, that is aldoxime, or HC double bond NOH, that is this is simple. We are say oxime. Okay, na? This is simple. We say like here OH. This is a simple. We say oxime functional group. Oxime functional group. If RH, we substitute RH, one alkyl group, one hydrogen. That is if we substitute one alkyl group, another alkyl group, R, that is known as ketoxime. Clear? Says or no? Anyone? See, this is C double bond N. Here OH. Here one lone pair also. Okay, not showing this. C double bond N OH one lone pair. This is all alkyl group. This is also alkyl group. Ante R C double bond N lone pair and OH. This is known as ketoxime. This is known as ketoxime. Okay. See, from this carbon, the shifted towards nitrogen. Okay, now this phenyl group are rearrangement. Okay, now rearrangement is nothing but, so within the reaction, okay, now within the reaction, the position of alkyl group are changed in like this pinacol rearrangement. You heard this pinacol rearrangement? First or second sem. Okay, so pinacol rearrangement. So this phenyl group is rearranged as nitrogen on nitrogen. Rearranged as nitrogen. See, this is N-phenyl benzamide. Okay, now N-phenyl benzamide. Clear? So, అర్థమవుతుందా?
Yes,
sir.
అర్థమైంది సార్.
రెస్పాండ్ ఇవ్వండి సార్. రెస్పాండ్ ఇస్తే నాకు తెలుస్తుంది మీకు
Okay, sir.
వింటున్నారా లేదా. ఓకే.
ఓకే
Okay,
సార్.
See, Wolff-Kishner reduction. Okay, na? This is maybe last one, Perkin and aldol. These are two very, very important. Okay. See, this is also all the name reactions.
Good morning, sir.
Okay. So see, these are all chemical properties. Just you write what are the chemical properties of aldehydes and ketones. Just starting with see. Addition of ammonia. See, number one, addition of ammonia and Kenny-Jarrow reaction. Number two, just to write. Then third one, Clemmensen reduction. And fourth one, Meerwein-Pondorf-Verley reduction. And fifth one, Tollens test. Sixth one, benzoin condensation. Seventh one, Beckmann rearrangement. And eighth one, Wolff-Kishner. These all are chemical properties. Just you have to write any 3 to 4. They ask, write the chemical properties of aldehydes and ketones. Direct question by 10 marks question. You have to write any 3 to 4.
Okay.
Otherwise, they ask to write the benzoin condensation and Perkin reaction with mechanism, or benzoin condensation or aldol condensation with mechanism, or Kenny-Jarrow reaction with mechanism. Okay?
Okay, sir.
See, Wolff-Kishner reduction. See, what is the name in this reduction means?
Reaction.
Addition of
Hydrogens.
Removal of
See,
oxygens.
removal of oxygen. Anyone takes place. Okay. Ketones are usually reduced. Okay, reducted through their hydrozones. Hydrazine converted into hydrozones. When the hydrozones are heated with sodium ethoxide, this is sodium ethoxide. This is a base, sir. Okay, now this is base. NaOET. Sodium ethoxide. It is a base. Base means it abstracts proton. It attracts H plus ions. Usually, ethylene glycol nitrogen is eliminated. The net reaction is conversion of carbonyl group into methylene group. Okay? See, so what is the this sir? Simple. So this is the reactant. So this is comes from comes from R C double bond O R NH2 NH2. This is hydrazine. This is carbonyl group. Simple loss of H2O. Simple loss of H2O. What is the reactant? R C double bond N NH2. These are same. Yes or no? Both are same. This one.
Yes. Yes, sir.
This is comes from. So how did this comes from? Aldehydes or ketones. Aldehydes or ketones. Reaction with hydrazine, NH2. Loss of water molecule, it gives hydrozones. Hydrazine is converted into hydrazone. So hydrazone, this is hydrazone. Okay, this is hydrazone in presence of NaOET, sodium ethoxide, converted into C double bond, converted into CH2. C double bond converted into simple the loss of N2. Okay, now the loss of N2, nitrogen gas is evolved, and RCH2R. This is alkanes. hydrogen of ketone converted into ante C double bond O converted into CH2. This is the main theme of reaction. C double bond O converted into CH2. Ketone converted into methylene. CH2 ante methylene group. Okay. So next, just to take screenshot and what are the writing, okay? Perkin reaction. Okay, now this is also important. Just you have to write just reaction only. Okay. See, when benzaldehyde is heated with acetic anhydride in presence of sodium acetate, cinnamic acid is obtained. Okay, now cinnamic acid is obtained. C6H5CHO. When benzaldehyde, benzene by aldehyde, that is aromatic aldehyde, is treated with acetic anhydride. Acetic anhydride in presence of sodium acetate. It gives C6H5CH double bond CH This is cinnamic acid. Okay, this is one of the carboxylic acid. Cinnamic acid are 3-phenyl acrylic acid. 3-phenyl acrylic acid is known as cinnamic acid. Okay.
Yes, sir.
So next, last one. Benzoin condensation is very, very important.
Sir, this one is enough.
So,
one reaction is enough for Perkin reaction.
Enough. Okay, now. So there are you have to remember very long mechanism.
Mechanism, yes, sir. Long.
So important mechanism. They ask for they ask like the question Perkin reaction. Okay. So see. So once again I will explain. No problem. So this is CH3COO minus means it is acetyl group. Okay, na a CH3COO minus C sodium acetate CH3COO minus Na plus CH3COO minus Na plus. This will attract the proton. This will attract the proton converted into acetic acid. CH3COOH is acetic acid and converted into carbon ion. C minus is nothing but carbon ion. So this carbon ion takes place by the electrophilic carbon of aromatic aldehyde. This electrophilic carbon of aromatic aldehyde. This carbon. See, this carbon is new bond. See this. The bond, new bond between these two, and the pi electrons towards oxygen. Means they get negative charge. Oxygen get negative charge. See, these both are same structures. Okay, now this is keto form. This one is enol form. You have to write any one this. Okay, now keto form and enol form. Then treated with H2O. Then treated with water molecule. Okay, sorry. The loss of water molecule. They converted into C. This hydrogen. Okay, now. So this hydrogen takes place towards this and loss of H2. Okay, now. What is the reaction occurred in this? C. Okay, now. Here two hydrogens are there. CH2 and above CH2. This hydrogen towards this carbon, carbon double bond and loss of H2. See, that's why C6H5, CH double bond, CH, C double bond O and so on. Okay. Next step, this hydrolysis will take place. See, here the bond breakage. Here HOH. See, C6H5, CH, C double bond O, OH. This is cinnamic acid and remaining is CH3COOH acid, acetic acid and cinnamic acid. This is a mechanism, very simple. Okay.
Yes, sir.
Next, Perkin reaction, just to practice 1-2 times, easy to remember. Okay.
Yes, sir.
Next one, very
You have to
important.
write the mechanism also, sir.
They ask for 5 marks, you have to write mechanism.
Okay.
Okay, they ask the Perkin reaction and write with mechanism. Okay.
Okay.
So, aldol condensation, what is Kennedy-Jarrow? Simple, again we say. What is Kennedy-Jarrow reaction?
Aldehydes having no alpha hydrogens.
So this is the difference between aldol and Kennedy-Jarrow.
Reaction.
Under Cannizzaro reaction, aldehydes having no alpha hydrogens. But here, aldehydes and ketones having alpha hydrogens. If alpha hydrogens are possible, the aldol condensation takes place. If there is no alpha hydrogens, Cannizzaro takes place. Yes? This is the difference. Okay?
Okay, sir.
See, symbol. So see the line, aldol condensation. Okay, now aldehydes and ketones having alpha hydrogen. See the main point. There is no alpha hydrogens on Cannizzaro. Here, alpha hydrogens on Cannizzaro. Undergo this reaction. The presence of dilute alkyl acetaldehyde undergo condensation to give beta hydroxybutyraldehyde or aldol. Beta hydroxybutyraldehyde or aldol. దీన్ని. Okay, na? Aldol upon heating loses water. It gives crotonaldehyde. Okay, na? It gives crotonaldehyde. An alpha beta unsaturated aldehyde. Okay, na? See symbol. Just you have to write like this. 2 moles. Okay, na? You know that what is alpha hydrogens? So this is functional group. Simple we say this is functional group. Okay, na? This is functional group. What is the functional group? Keto or aldehyde, anyone. This is functional group. Adjacent carbon is alpha carbon. This carbon have hydrogens. This carbon have hydrogens. These hydrogens are called alpha hydrogens. These hydrogens are called alpha hydrogens. See, just to see acetaldehyde we are taking acetaldehyde. So this is functional group. Yes or no? Aldehyde functional group.
Yes, sir.
What is adjacent carbon is carbon with one carbon is how many hydrogens are there?
3.
3 and 3 are alpha hydrogens. And this aldehyde having so akkade in the Cannizzaro see formaldehyde is formed and C6H5 C double bond OH. There is functional group. There is no alpha hydrogens. There is no alpha hydrogens in this, and this is functional group. There is no alpha hydrogens. Only hydrogens are there. If alpha hydrogens are attached with carbon, that is alpha hydrogens. Okay, now there is no alpha hydrogens. These are in Cannizzaro reaction. These acetaldehyde CH3CHO in which reaction? Aldol condensation. These two are Cannizzaro. This one is aldol. See the difference between. Okay. See. So this is 2 moles of aldehydes, 2 moles of acetaldehyde in presence of OH minus. In presence of OH minus. OH minus is nothing but base. Okay, now it gives which one? Beta hydroxy. This is functional group. This one is alpha carbon. This one is beta carbon. If beta carbon contain which group? Hydroxy group. Yes or no?
Yes, sir.
Beta hydroxy. How many carbons are there in the straight line?
4 carbons.
4 means butane. Butane. Yes or no?
Yes, sir.
Butane. What is the functional group? Aldehyde. So aldehyde. Beta hydroxy butyraldehyde. Beta hydroxy butyraldehyde is nothing but is known as aldol. The name is aldol. Aldol loss of water molecule. So how the loss is water molecule? Simple. This is one hydrogen. Okay, now the hydrogen, the bond shifted towards this carbon and loss of H2. That's why CH double bond. Yes or no? CH double bond. Yes or no? Clear?
Yes, sir.
Okay. So this is take place. Yes, me. Please mute. Okay, clear? Any doubts? Okay, these see the definition. See the definitions. Aldehydes or ketones having alpha hydrogens undergo this aldol condensation. 2 moles of acetaldehyde in presence of OH minus, NaOH or KOH. NaOH or KOH. NaOH means Na plus OH minus. KOH, K plus OH minus. Okay, now 2 moles of acetaldehyde undergo in presence of OH minus. It gives beta hydroxybutyraldehyde is nothing but aldol. Aldol, loss of water molecule, it converted into crotonaldehyde. This reaction is called aldol condensation. Okay?
Yes, sir.
See the mechanism, very, very important. Okay. See, this is carbon. Okay, na CH3, CHO. Okay, simple. OH minus. OH minus is base. Base is always attract. Which one? Proton. Yes or no? OH minus is attract with proton. Okay, na H plus. So
Yes,
takes
sir.
place loss of water molecule. So the bond shifted towards carbon. C get negative charge. See this. Carbon and positive. Okay, na carbon are formed. Yes or no? C minus in second step. You are observing? If C minus is there, that is carbon ion. C plus is there, that is carbocation. C dot, that is free radical. C dot is there, that is free radical. Carbocation, carbon ion, and free radical. Carbon free radical. Okay. Here, symbol loss of water molecule. Loss of water molecule. It get carbon get negative charge like carbon ion and oxygen ion. Okay, na the bond shifted towards this. The pi electron towards oxygen. It get negative charge. Okay. Then oxygen ion react with another aldehyde. Okay, now we are taking how many aldehydes?
2 moles of
2. Yes, sir.
yes, sir.
2. This oxygen ion reaction with another molecule of aldehydes. Another molecule of aldehyde. This carbon ion attack it, electrophilic carbon, and again the pi electrons towards oxygen. The oxygen get negative charge. See this. The oxygen get negative charge and carbon bond on the carbon. How many hydrogens are there? 2 hydrogens and aldehydes are there. Okay. See next reaction again reaction with H2O. Again reaction with H2O. So H plus ion attack it O minus. So O minus gets converted into OH. O minus converted into OH. Here again loss of water molecule. See H is going to this carbon double bond and loss of OH minus. See H2O is lost. Then CH3 CH double bond CH CHO. This is called protonaldehyde. This is called protonaldehyde. Simple we say. Okay, na we say simple CH3 we are taking protonaldehyde. If we are taking C6H5 that is cinnamaldehyde. Okay, so in aldol condensation we are taking only aldehydes and ketones. We are taking only aldehydes and ketones having which hydrogens?
Which
hydrogens are alpha? That is the main important point you have to write in your exam. Aldehydes and having ketone alpha hydrogen. That is the underline point in your examination pattern. Okay, simple examples. Okay, see CH3 C double bond OH. So if A, B, and C, HC double bond OH, and C6H5 C double bond OH, D, both B and C. So which are question is which are undergoing Kenny-Jarrah reaction? Which are option is correct? Kenny-Jarrah reaction.
Second one, sir.
A, B, C, or D. Which option correct?
B1, sir.
B, sir.
Huh?
B1, sir.
D, B,
B, sir.
B for boy, sir. B.
No.
Then, sir. A.
C.
Option C, sir.
This is function group aldehyde. There is no alpha hydrogens. This is also function group aldehyde. There is no alpha hydrogens. C6H5 also benzaldehyde and formaldehyde. So we are in Kenny-Jarrah reaction. Benzaldehyde, formaldehyde, and phenoldehyde. These are Kenny-Jarrah reaction. This is benzoin condensation. This is aldol condensation. Okay, na? Option is D. Both B and C. Okay, na? Involved in Kenny-Jarrah reaction. A involved in aldol condensation. Okay.
B, C also, sir.
See, I will show Kenny-Jarrah reaction once. See the example.
Okay, sir.
See this reaction.
Yes, sir.
See HCHO, C6H5CHO, CH3 taken 3
H5CHO.
Formaldehyde, benzaldehyde, phenoldehyde. These are Kenicharo, CH3, C double bond OH, acetaldehyde. It is aldol condensate.
Condensate.
అర్థమైంది కదా?
Okay, sir.
Okay, so this is final end of aldehydes and ketones. Okay, so this is aldehydes and ketones. How the questions are come? See the questions. Okay, you see the seventh question. Benzaldehyde with KCN, which reaction? Which reaction? Tell me.
Aldol reaction, sir.
That is not aldol.
Benzoin condensation.
Benzoin condensation. Okay, na benzoin benzaldehyde converted to benzoin condensation. Okay. See the long answer questions. సో ఇక్కడ ఏంటంటే డైరెక్ట్ గా ఇచ్చాడు, ఇలా ఇవ్వడు ఎగ్జామ్ లో. ఎసిటైల్ టు ఎసిటలోన్ ప్రొపిలిన్ టు ఇలా ఇవ్వడు.
సార్ క్వశ్చన్స్ చెప్తారా? ఈ యూనిట్ నుంచి ఎలా అడుగుతారు క్వశ్చన్స్? లాంగ్ షార్ట్
చెప్తున్నా చూడండి.
వెరీ ఇంపార్టెంట్ క్వశ్చన్స్ చేయండి సార్.
సి రైట్ ఎనీ 3 ప్రిపరేషన్ మెథడ్స్ ఫర్ aldehydes and ketones. Write any 3 preparation methods for aldehydes and ketones.
Yes, sir.
Write any chemical properties. Write the chemical properties for aldehydes and ketones. These are the 2 questions. Enough.
Okay, sir.
So, sir, what are the chemical properties? Means all the chemical properties. These all are. They like individual, and also this what is addition of ammonia. See this. Okay. So I am observing hydrazine, phenyl hydrazine, hydroxylamine, semicarbazate. Yes or no?
Yes, sir.
So this is what is the heading is addition of ammonia. First chemical property. Second one is Kenijaro reaction, also chemical property. Lemonson reduction, also chemical property. Irwin-Conrad, Tollens, benzoin, Beckmann, Ulf-Kirchner, and Perkin and aldol. These are all chemical properties. You have to write any 3 or 4. Yes.
Okay.
Or they ask like direct questions. Now last time they asked for 10 marks question. They asked give the following reaction with mechanism. They asked aldol and benzoin. They asked aldol and Perkin and Kenijaro and benzoin. Okay.
Okay.
This is questions for only 2 questions: chemical properties and preparation methods. Preparation methods I am telling only 4. You have to write any 3. Okay.
Okay, sir.
See the carboxylic acids. Is it chapter is over? Last class Sunday. Yes sir. No.
Nomenclature.
Nomenclature is over. See the question direct. Carboxylic acids. You know that COOH. Okay. RCOOH is known as carboxylic acid functional group. RCOOH is known as carboxylic acid functional group. The carboxylic acid name end with oic acid. Okay, na? Oic acid. So the name end with oic acid, that is confirmed carboxylic acid. You know that CH3COOH. How many carbons are there?
2 carbons.
2 means, what is the name? 2 means?
Eth.
Ethanoic.
One carbon, single bond or double bond?
Single bond.
Single bond means ane.
Ane.
Okay. COOH, the name end with eth
Oic.
plus ane plus oic acid.
Oic acid.
Okay. What is the name? Complete name?
Ethanoic
ethanoic acid. Ethanoic acid. Ethanoic acid. General name is acetic acid. Vinegar. You know that vinegar.
Yes, sir.
Sir.
CH3COH. General name is vinegar, and IUPAC name is ethanoic acid. Ethanoic acid. Okay.
Okay, sir.
So CH3COOH. Now, what is the name? How many carbons are there?
3
Three.
carbons.
3 means
Pro.
propanoic acid. Prop plus N plus oic acid. Propanoic acid. Okay.
That's it. Yes.
HCOOH. How many carbons are there?
1, sir.
1 means
Methanoic.
methanoic acid. Methanoic acid. The common name is formic acid. The common name is formic acid. Okay.
Yes, sir.
These are like carboxylic acid general. Okay, na? They ask the functional group. What is the functional group showing as carboxylic acid? Just you remember RCOOH is carboxylic acid. RCOOH is carboxylic acid. Okay.
Okay, sir.
See the examples. Number of examples. Okay, see the oxalic acid, COOH, COOH, dicarboxylic acid. This is also di. Di means 2. Oxalic acid, ethane dioic acid. These are 2 malonic acid. Okay, na? These are succinic acid, glutaric acid, and adipic acid. And all are, how many carboxylic acid are there?
1, 2, 3, 4, 5.
ఎన్ని ఉన్నాయి ఇందులో ఎన్ని ఉన్నాయి కార్బాక్సిలిక్ యాసిడ్స్ 2 దీంట్లో 2 దీంట్లో
2.
So all are example for dicarboxylic acid. All are example for dicarboxylic acid. Okay. See, so the question is, then from this lesson they ask general preparation method for carboxylic acid. Again, the question I asked like this: write the general preparation methods for carboxylic acids. Okay.
Okay, sir.
See, oxidation of alcohols and aldehydes. So first method, remember oxidation of alcohols and aldehydes. You know that what is oxidation?
Addition of oxidants, reduction of hydrogens.
Okay. So, oxidation cheppina alcohols ni. Okay na, simple good pettukondi. So this is preparation methods for aldehydes and also preparation methods for carboxylic acid. Rendu kuda cover aithayi ikkada chudandi. Okay na. If alcohols are oxidized, it converted into aldehydes. Aldehydes are oxidized, it's converted into acids. Okay na. So these are 2. Okay na. Important methods, simple. See, RCH2OH. You know that OH is hydroxy group, alcohol group. CHO is aldehyde group. COOH is
Oxalic group.
carboxylic acid. Yes or no?
Yes, sir.
Simple. Just you put CH3OH methanol, CH3CHO ethanol acetaldehyde, and CH3COOH acetic acid. CH3COOH acetic acid. Simple ikkada em pedtam oxygen, దీని నుంచి oxygen. Simple. This is a simple method for aldehyde preparation as well as carboxylic acid preparation also. See, methanol, CH3OH, methanol, not methanol, methanol is converted into only 1 carbon, formaldehyde, oxide. Ikkada em jarigindi? What is the reaction? Addition of oxygen or removal of hydrogen in this reaction. How many carbons are there in methanol? How many hydrogens are there?
1 carbon, sir.
3 hydrogens are there.
4 hydrogen and 2
3
Hydrogen.
hydrogens are there.
4, sir.
Here formaldehyde, how many carbons?
1 carbon, 2 hydrogen, sir.
Which reduced? Carbons reduced or hydrogens reduced?
Hydrogen removed, sir.
Hydrogen removes means oxidation. Yes or no?
Yes, sir.
Here, how many carbons are there? 1. Here, 1. Hydrogens, 2. Here, 2. Oxygens, 1. Here,
1.
Oxygen 2, sir.
2.
2. Here, what the change takes place? Addition of oxygen. Yes or no?
Yes, sir.
Yes, sir.
So here, simple. I will like to say the methanol is okay. A removal of hydrogen takes place from aldehyde to alcohol. Addition of oxygen takes place. And within the reaction, hydrogen addition, removal of hydrogen and addition of oxygen. Both are oxidation. Yes or no?
Yes,
Yes,
sir.
sir.
So this is oxidation of alcohols. If methanol takes, it is formaldehyde and methanoic acid. This is formaldehyde, this is formic acid. Here taking ethanol. Ethanol is converted into ethanol or acetaldehyde and acetic acid. Just you say simple IUPAC name or general name. Ethanol or ethyl alcohol. The name is common name is ethyl alcohol. IUPAC name is ethanol. Here, ethanol is IUPAC name, acetaldehyde is common name. So acetaldehyde is oxidized, it converted into acetic acid. Acetaldehyde, acetic acid. Okay, na? Ethyl alcohol into acetaldehyde, acetaldehyde into acetic acid. Clear?
Yes, sir.
Simple methods, sir. Simple preparation methods. Number 2. Okay, na? Number 2 method. Just you have to write direct. Don't go for any test and test papers. Okay, just you have to write this one only. Enough. Then hydrolysis of nitriles. You say what is? You say C double bond N. Cyanides. Yes or no? CN is cyanides. Cyanides, another name is nitriles. Another cyanides, another name is nitriles. See, in alkyl cyanides, see, alkyl cyanides, or another name is nitriles, are hydrolyzed. Hydrolyzed means addition of water. In presence of acid or base, carboxylic acid are obtained. Okay, simple ga RCN. Okay, na RCN reaction with water molecule in presence of acid or base, H plus or OH minus. See, H3O plus or OH minus, it gives RCOOH plus ammonia. See, we are taking methyl cyanide in presence of water, it is gives acetic acid. It gives acetic acid and ammonia. Clear?
Yes, sir.
Simple. Benzyl cyanide and benzyl cyanide C6H5CH2CN. This is benzyl group, this is cyanide. It gives phenyl acetic acid. Phenyl acetic acid. You have to write any one. Okay, na? In your examination pattern, just you have to write not R. Okay, na? You have to write direct example.
Into your reactions is enough, sir.
Any to 1 to. Okay, na? Don't write general reaction. Just you have to write direct reaction. Or you have to write general reaction. In the place of R, we have to put CH3, C2H5, C6H5, any alkyl group. Okay.
Okay, sir.
Next, carbonation of lignite. Third property, sir. Third preparation. No, sir, not property. Third preparation method. See, carbonation. In carbonation, that is the meaning. Reaction with carbon dioxide. Reaction with carbon dioxide. See, when Grignard reacts with carbon dioxide, addition product is formed. These on hydrolysis gives carboxylic acid. See, the reaction takes place like C double bond O. This is C double bond O, carbon dioxide. Here R MgX. R minus MgX plus. This is Grignard reagent, sir. R MgX is nothing but Grignard reagent. This is electrophilic carbon. R minus attacks in this place. Okay, now the bond shifted towards O. O means O get negative. See the ఎలా వస్తుంది చూడండి, ఇక్కడ ఎలా వస్తుంది అంటే R ఇక్కడ ఏముంది, R కి కార్బన్ కి ఉంది, ఇంకేముంది C డబల్ బాండ్ O, సింగిల్ బాండ్ O మైనస్, ఇక్కడ ఏముంది O మైనస్ అంటే పక్కన ఏమొస్తుంది MgX. ఓకేనా, MgX ప్లస్. సింపుల్ గా దీన్ని హైడ్రాలసిస్ చేస్తే ఇక్కడ బ్రేక్ అయితే ఇక్కడ OH వస్తుంది, ఇక్కడ OH వస్తుంది. ఏంది RCOOH, RCOOH ప్లస్ MgOH. See the reaction కింద చూడండి, అదేనా ఉంది, R C double bond O minus MgX plus. Yes or no?
Yes, sir.
ఇక్కడ మధ్యలో బ్రేక్ అవుతుంది O ఆక్సిజన్ కు బిట్వీన్ మెగ్నీషియం, ఇక్కడ హైడ్రోజన్, ఇక్కడ OH. RCOOH plus MgOH. Simple preparation methods for carboxylic acid. Okay.
Yes, sir.
So these are the three simple methods. These are the three simple preparation methods for carboxylate. They are like you have to write any three.
Okay, sir.
Any three. This is Grignard reagent treated with carbon dioxide. It gives an addition product. The addition product on hydrolysis, it gives carboxylic acid. Just in the place of R, just you have to write CH3 group enough. In the place of R, you have to write CH3 group.
Yes,
It
sir.
gives acetic acid. See the reaction. Yes or no?
Yes, sir.
Yes, sir.
See the reaction. It is one enough. Okay.
Okay, sir.
Okay. So time is completed. We continue tomorrow.
Sir, for each preparation, we have to write two reactions.
Only one enough.
Okay, sir. Okay.
You have to write general, not reaction, just direct reaction. Okay.
Okay, sir.
Sir,
Okay.
అది సెకండ్ సెమిస్టర్ కి సెకండ్ సెమ్ కి కొన్ని క్వశ్చన్స్ ఇంపార్టెంట్ క్వశ్చన్స్ ఇస్తారా సార్?
1 minute. Second sem.
అవును సార్.
ఏమున్నాయి లెసన్స్?
లెసన్స్
హాలోజన్ డెరివేటివ్స్, హైడ్రాక్సీ కాంపౌండ్స్ అవేనా? ఈథర్స్,
అవే అనుకుంటా సార్.
సాలిడ్ స్టేట్ ఫేజ్ రూల్. ఓకే, అదేనా?
అవును సార్, అవే సెకండ్ సెమ్. అవే సార్ సెకండ్ సెమ్.
సో షేర్ చేయడానికి ఇప్పుడు ఉన్నాయి, ఎలా షేర్ చేయాలని? ఈ గ్రూప్ ఏమన్నా ఉందా మీకు?
ఉంది సార్.
ఉంది సార్, మీ నెంబర్ షేర్ చేస్తే మిమ్మల్ని యాడ్ చేస్తాను అందులో.
ఓకే, సో యాడ్ చేయండి, నేను అలా షేర్ చేస్తా.
ఓకే.
సో నోట్ నెంబర్ 9963
9963
613
613
108.
ఓకే సార్.
ఓకే సార్.
ఓకే, ఆల్రెడీ పెడుతున్నా చూడండి నంబర్ కూడా. వచ్చిందా చూడండి?
వచ్చింది సార్.
వచ్చింది సార్.
సో గ్రూప్ యాడ్ చేయండి, నేను షేర్ చేస్తా. సెకండ్ సాయి రెడ్డి. టైం టేబుల్ చూడలేదా? టైం టేబుల్ చూడండి, క్లాస్ వింటున్నారా?
నేను చూడలేదు సార్.
టైం టేబుల్ లో ఉన్నాయి, ఏ లెక్చర్ ఎవరు ఇస్తారు అనేది టైం టేబుల్ లో ఉంటాయి. ఓకే, సో
టైమ్స్ డేట్స్ మెన్షన్ చేశారు సార్ గ్రూప్ లో.
ఓకే ఓకే, సో విల్ కంటిన్యూ టుమారో సేమ్ టైం.
ఓకే సార్.
గైస్, నా నంబర్ ని కొంచెం
థ్యాంక్ యూ
గ్రూప్ లో యాడ్ చేసుకోండి ప్లీజ్.
కెమిస్ట్రీ గ్రూప్ ఉంటే కొంచెం ఆ లింక్ బిఆర్ఏఓ
షేర్ చేయండి. ఎవరి దగ్గర ఉంటాయి?
ఎవరి దగ్గర లేదు. యాక్చువల్లీ మనం ఒక గ్రూప్ క్రియేట్ చేసుకుందాం.
హలో, ఆల్రెడీ గ్రూప్ ఉందండి కెమిస్ట్రీకి.
అవునా? ఈ నంబర్ కి ఇప్పుడు నేను చేంజ్ చేసిన నంబర్ యాడ్
అక్కడ
చేసుకుంటారా?
గ్రూప్ లింక్ పెట్టాను, దాని యూజర్ జాయిన్ అవ్వండి.
ఓకే ఓకే,
కింది.
థ్యాంక్ యూ.
థ్యాంక్ యూ.
రాకేష్ మీరా?
ఓకే ఓకే. ఓకే, అంతకు ముందు ఉన్న గ్రూపే కదండి ఇది?
ఇది స్టార్టింగ్ ఫస్ట్ సెమ్ నుండి ఉన్న గ్రూప్ అండి. ఫస్ట్ సార్ నేను తెలియదు కానీ ఆ సార్
ఫస్ట్. ఓకే ఓకే, దేవేందర్ సార్ ఉన్నారు ఫస్ట్.
ఎస్, దేవేందర్ సార్ అప్పుడు చేసిన గ్రూప్ ఇది. ఆ సార్ కూడా ఉన్నారు ఇందులో.
ఓకే ఓకే.
ఒకవేళ ఎవరికైనా లింక్ కావాలంటే గ్రూప్ డిస్క్రిప్షన్ లో ఉంది, కాపీ చేసి వాళ్ళకి పేస్ట్ చేయండి.
ఓకే ఓకే